Hi, today we're going to be talking about Java EE web technologies. Mostly when people talk about web technologies, there's many protocols. There's things like FTP or even transfer via SSH or even torrent or even other and a bunch of other technologies around that are available on the internet. However, when somebody speaks in general terms about web technologies, most of the time they refer to the protocol HTTP, which stands for Hypertext Transfer Protocol. The idea is very simple. There is a client and there is a server. And the idea is that the client sends a request to the server and the server processes something. There's multiple layers, and I'll explain this in a second. But ultimately, the server sends a response. It's a very simple transfer protocol. In the server, typically, there is the static content handling of things, that it's more like a web server like Apache or Nginx. And this part doesn't have the capacity of running any particular code. So usually we send it to a backend runtime, and this is where the backend technology comes from, the term backend, because it's actually sent to what is known as a CGI, or a Common Gateway Interface. This thing, initially it was C++ programs that will execute in a specific directory from the web server, and those would execute, and then the output would be sent to the response. But that was deemed insecure. And actually, these guys are the ones that access a database or another API or perform certain logic. But that was actually deemed insecure because at that moment, in the late 90s, when you did a CGI either via Perl or via an executable code, it would start thousands of processes because it would be handled one per each request. So there are better mechanisms now that are handled by software like Nginx or Apache, and then they send it back to technically what is called the front end. The front end is essentially the web server because it's going to be sending static content. It's not sent to a processing things. If not, it's just sending HTML, CSS, and JavaScript, which essentially are dispatched from here, and the processing is done in the client, not on the server. So if the processing is done on the server, it's backend. If the processing is done on the client, is the front end. Therefore, this is just reading and sending the files for the front end. This is just forwarding the request for the backend, where it is connecting to a database or an API. I want to just talk about a couple things. One is about the request. The HTTP request is made basically of three elements. One, the URL or the address that it's calling, and usually it has different parts. One is a protocol. It could be either HTTP or HTTPS, and usually we know the protocol because it's separated by the colon / and that says what protocol it's running on. Then it is the actual domain name, the fully qualified domain name, and the TLD, which is this part, the .com, the .uk, the .eu, whatever it is. TLD stands for top level domain. So essentially a domain name, the top level is reserved for the .com, then google.com, then www.com. So it's essentially resolving the name in this direction. Like if it was going and solving it from, and it's solving it in this direction, like this. So it starts from the .com, then the DNS will try to solve who is Google, and then which one of all the servers is www. In the case of Google, sometimes you have like mail.google.com, that's Gmail, or images.google.com, that's Google Images, and so on. So that's how the domain name is resolved. But right now we're not going to review that part of network communications. We're going to talk about HTTP. And then afterwards, we have the address. The address is the path essentially to that it's going to resolve that request. After the question mark of a URL, anything that has a word equals value, it's a key pair value of parameters that are passed to the URL, and then the URL can use those to retrieve those. heads up, that is quite insecure, and that is only accepted in one of the methods. We're going to discuss that in a second. The other element is the header is the first part of the HTTP request that contains a bunch of metadata, essentially in a key pair value as well, where it tells you what type is the encoding of the data that you're sending, and the user agent, what kind of browser you're using to access things. The other one is the method, which could be one of the four main methods, and we're going to explore that in a second, and the body, which contains the data of the request. Sometimes you might not even have a body. So, we were talking about the request methods, and the request methods we have basically get. Get is, in short, the read-only version of things. So it's not secure to send parameters via the URL, because if it is intercepted, even if it's encrypted via HTTPS, the parameters are not encrypted. The URL is never really, is not very encrypted because it's accessing the request and then sending all the information for the handshake and security stuff. So the URL is really not very secure. So nothing in reality other than, information that you don't really care about should be passed as a parameter. If you need to pass certain other information, I would suggest that you use the post. Now, there's more request methods, but what a RESTful API convention has come to be is that you have essentially read, create, update, and delete. So essentially you have your CRUD operations. I also included head here because head is just a way to ping the server and just say, hey, you can do a pre-flight request, or you can just ask certain things like, hey, what do you actually accept, and things like that. It's just a small type of request. But in reality, for read, create, update, and delete, you use get, post, put, and delete. Get being the read, post being the create, put would be the update, and the delete would be essentially delete. Okay, so now that we understood the basics of an HTTP request, now let's talk about the basics of a response. Response is very similar to the request in the same way that it has a header and a body, but the only thing that it doesn't have is a URL, because in reality the response is the server responding to you. It's not like you are trying to search the address on the internet. At that point that you go into the communication in, for example, this slide here, you go through the entire online situation to go from the connection all the way until you find the server. That's when you hit the URL, and then the server unpacks. The server knows where the request came from, the IP, so it doesn't really need to trace back the domain name. So it goes from IP to DNS to figure out what is the IP, and then it goes into the server. So that's why you needed the address. But in the response, you really don't need an address to be able to communicate with the client. So therefore, you only have the header. You have the header and the body. The header and the body. Another aspect that is returned in the header of the response is the status code. And the status code is essentially a series of numbers that tells you how the server responded to the request. So if you want to use some of the basic HTTP methods, this is summarized. I'm sure that you have seen 404 not found or 500 server error. Well, those all map to this table here. So you have information responses, anyone that starts with a 1, so for example status 100, or successful responses like 200, which means okay. Essentially every time that you access a page, the server responds okay, and then serves the data. There are certain ones that when a page has been changed from a place to another and you want to redirect people, you can do a redirection message. an example of that would be when you are logged out and it redirects you to a login page. The server can respond with a redirection message that your browser will interpret and then put you in the right page. So 302, 304 are common, either permanent or temporary status codes. So 302 is one of those, 304. And I would recommend that every time that you are actually looking for some of those, you look at HTTP status codes, and that's a good way of like telling a client the actual error. And it's a good way of them being able to handle it. For example, at 404, whenever you're deleting or removing a resource from a web server, you can essentially tell them that this resource doesn't exist. Now, if it was moved, it would be useful to have a 300, but since it's gone, you would have a 404. And sometimes certain things in the connections just break, and you need to have a way of telling it, hey, I can't handle this right now. And sometimes it just be, it might be a denial of service or something like that, and the web server and the backend interpreter, the backend runtime, might be disconnected, and that's returning something like that, even though that you might not want to return it.